Hi, this will be a tutorial about slicing and recoloring and masking within within Microscopy Nodes 3.1, Blender 5.2. And I think this is some of the exciting part about Microscopy Nodes 3.1, because we can now really start treating segmented regions or otherwise described regions of our data differently and give them different color maps, different animation, and different settings. And for this, I will first delete everything in our scene, and then I want to load a dataset. By default, our loading will be with the shader slicing, which will be applied only in the shader, but here and that can only be a single box, and it sometimes gives slightly more clean slicing, but it is a lot less flexible. So to show off some more of the flexibility, we're immediately going to switch to the geometry-based slicing and press load. And we can then go into the geometry nodes and find that we've gotten, instead of doing shader-based slice cubing, we have a masked grid node per channel, where the grid is masked with our slice cube, which means that our slice cube just functions exactly the same way as it used to. The box mode is the default mode for just the slice cube, but we also have different modes where we can actually load in different objects, such as an object, a collection, a mesh, or another volume, which is a grid. And we can then see that this does almost exactly the same thing. Here we just see that if we put the slice cube in object mode, we get a resolution at which the object is evaluated. So if we make this smaller, we can see that it does the same slicing as our slice cube. The only real difference with this is that we can now also put in an object that is not a box. So for example, if we want to put the put in a sphere, like an icosphere, and I want to make this transparent by turning its alpha down, we can go into the volume and redirect the NHS ester visualization to the sphere instead of the box, and we can see that we're showing only the data inside of our object. And it is not completely round, and that is because of this mask resolution. So if we take like even smaller, we can see that we get to our rounder data. However, this is not the only thing that we can do. This has not just an inside mask, but also an outside mask output. And this is where we can just add a new channel to show the outside or show a differently created version of our data. We can also concatenate multiple of these boxes to say if inside here and outside here, or outside here and inside here, or inside both of these, we do a specific thing. But right now, let's just visualize also the outside of the mask. For this, I'm going to add a channel here called outside NHS, and connect the outside masks to this. And this currently doesn't show up because it needs to be shown within the shader. And for this, we need to go into the shading tab for this, where we had all of our different channels. And we can add, under the add menu, an empty channel, which needs to have the same name, outside NHS, as we set in our geometry nodes. So right now we see that we have a purple version and a blue version, which are immediately updated from this mask. And so then we have a mask in Blender, so then we can also start doing things like sculpting that object. So we can start tearing this in different directions, or we can, instead of using a sphere-like object, we can also use something that is generated from the data. So if we've loaded a label mask or surface, we can actually use that to modulate our data. So to show how that works, I will load a FIB-SEM dataset with annotated masks, annotated in Amira, and the link for this will be in the description as well. And in here we find multiple channels of annotations, but we're only going to keep the chromosomes and the data and turn off the light bulb so that we immediately have scattering data. And we'll do this at the very small scale because it will make the rendering a little bit faster, and then we can later upscale this. Well, actually I might go one scale higher than this because we can see that it's extremely fragmented. And here we have a reasonable scale to work at with inside the label mask. So let's first just slice in Z by moving with G and Z through the axis, and then we can start to see the slivers of the label mask actually being hit but being occluded by the volume right now, and the label mask is also sliced by the slice cube. So what we can first do is switch in the volume. In the geometry nodes of the volume, we can again set the object of the masking to the label mask itself. And then we can set this to a much higher resolution, and we can start to see the meshes and the volume of the data start to overlap. And we see that this is also still sliced by the slice cube, even though this is not connected. And that is because the label mask itself is masked. So if we circumvent that, then we just see completely all of our chromosomes as separate objects. And what's also nice about this is that we actually have in there, we still have all of our original pixel values. So we can actually use, not that these are extremely interesting here, but we can actually still show all of our individual pixel values. One way that we can kind of show this is if we build a second channel here, which is data slice cubed. Then we can copy the mask grid. We can also just always find this in add microscopy nodes masking, mask grid and mask mesh. Put in the grid and we put back in the slice cube. And then make a new channel that is the exact same as everything in here, except that it pulls data slice cubed. Add this to our sequencing. We can see that we now have our data and the part that we've annotated in our data as which are being sliced differently. And we can start to we could now animate the slice cube to start to show this. Another cool way to use this is even with the same slicing is to just be that this allows us to recolor individual regions where we, for example, just show the normal data in white or black to white, and then we have a different colored region for our actual data that we're interested in, our annotated data. So this allows us to, within EM data, show both the data and our segmented regions in the same view without having to go to surfaces. Because often in EM data there's just people only show a surface render, and then you lose all of this context of what the pixel values in those regions actually are. However, there is one thing to note in here, and this is worse right now because we are in a very downsampled version of the dataset. These masks, if we rotate the slice cube, we will see this. These can actually start to get an artifact where we see the actual striation of the voxels that the slicing object makes. And this is because the mask is actually a voxel level mask, and the voxels are then as blocks going into the shader. In our normal shader-based slicing, we will just get a completely smooth surface if we rotate the slice cube, because that is all calculated on floating point position of the traced rays. But here, because we make this jagged array and then just send the array into the shader, this can cause these kind of artifacts where you have this, which is striation. If we now scale this up and reduce the go to a higher resolution, it will make some of this better. However, this is a feature that will always kind of exist in here, and that's useful to know. The other thing we can now do with the sliced regions is that we could actually use the sliced region to also reload only that sliced region to a higher resolution, but I have a separate video for this. So I hope this helps to show how you can kind of approach recoloring regions and using masked regions within Microscopy Nodes 3.1. If you need any help, please reach out on the ImageSC forum, and thanks for watching.